Hi, I'm Dave Smith. I'm a senior Android developer with Double Encore, an embedded Android enthusiast, and I teach Android classes for NewCircle. Today, I'd like to share with you some tips for navigating the source code of the Android framework. As Android developers, I believe this is an underutilized skill that we should be striving to hone. Because Android is an open source framework, we can investigate its implementation and gain a unique depth of understanding into how it works and how to make it best work for us. Documentation can be wrong, outdated, or even lack specifics, but the source code can never steer you wrong. This is not to say that the SDK documentation is of no use, but we cannot always rely on it to explain every behavior that might affect us. Additionally, the source code can be quite instructive in implementing performant code for requirements that may be similar to, but not quite the same as, the framework components. I'm going to show you a couple different tools and methods of getting into the source code, from the light and simple to the deep dive. We'll start off with some tools you can use inside of your browser to quickly and easily get access to the source of individual class elements from right within the SDK documentation you're likely already familiar with. The first step is going to be to make sure that you have Google Chrome installed. Both of the source diving tools we're going to look at in this section are browser extensions that only work in Chrome. If your daily browser preferences lie elsewhere, I'm hopeful that exposure to these tools will cause you to reconsider, or at least while you're developing. The first tool we're going to look at is the Android SDK Reference Search by Roman Nurek. This extension provides two major benefits. The first is, in addition to the omnibar allowing you to jump directly to reference documentation for any class of interest. The second, and more salient to our discussion here, is the addition of the View Source link that will be added to all the doc pages so that you can link directly from the reference docs into the source code for that class. From within the Chrome browser, we need to gain access to the Chrome Web Store. Now, the Web Store can be accessed either from the Apps button on your browser tab's homepage or by just going to chrome://apps. And we can select the store here, and we'll have the option to look up this extension. So we're going to search for this extension, just SDK Reference Search ought to do it. And the one we're interested in here is this Android SDK Reference Search. So I can click on that, and you can start to see just from these screenshots the two features that I've already talked about, the omnibar search and the View Source link. So to install this into our browser, we just need to click on this button up here. Answer any questions it may have for us, and we're ready to go. So now, in order to use this extension, all we have to do is prefix what we want to search for by typing AD space. And you'll notice that it automatically turns into the Android SDK Reference Search there at the beginning. So now I can start searching for any framework class that I would like to get the documentation on. Let's say I want to figure out more about intent service. So I can start typing intent service, and you see as I'm typing, it's filtering search results for classes, the training pages, and everything else that's on the SDK site. And once I've found the class that I'm interested in, I can just hit enter and jump directly into that page on developer.android.com. Now that's cool, but what we're really interested in is the fact that now we're here, we have this View Source link attached to the class documentation. So if I go ahead and click on that link, now I go from the documentation into the source code for this class. So you may notice that by default, what I'm looking at is the master branch, but where I am right now is in the web repository of the AOSP. So I'm looking at the actual source code for intent service that is implemented on this device. So at this point I can go through, I can look and see exactly how intent service is put together. You can see in general it's actually an extremely simple class. It's less than 200 lines of code. And I can learn what I need to from this example. Now, I mentioned that this shows up as the master branch, and you may be more interested in looking at a specific version that goes along with a specific version of the Android releases or the other pieces of the source code. So in order to do that, we may want to change this branch to something more specific. Now, there's a couple ways you can do that, but typically the easiest way is just here in the URL, change this master to the name of some other branch that you're interested in viewing. So for instance, I'll change this to the latest release and say we want to look at the KitKat release branch. And you see that the URL changes here. And now what I'm looking at is the version of intent service that was basically shipped with the KitKat release. Now, the next question is usually, how did I come up with that branch name? And if we go back to this top level of the framework project that we're in, you can see that there's actually a list of all these branches and tags for the Android source. So if I click on more, I can get a list for all of these. So you can see, if you haven't seen this before, that the Android source is typically tagged with individual branches and reference tags for major releases, dev releases, and even point revisions and bug fixes. So if at any point you want to look at a specific version of the Android source, you can just change from master, which is what the reference search plugin does for you. You can change that to any one of these other branches to look at the specific version of your class for Froyo, Gingerbread, or anything along those lines. Okay, so the other interesting thing to notice here is that this doesn't just work for classes in the core framework. It works for pretty much everything that is on developer.android.com. So if I come in here, I can also search for a class like ViewPager. Now, ViewPager is interesting because it's only available in the support library. It's not part of any specific release of Android. But yet again, if I come in here, I have a view source link, and if I click that link, it will take me to the source code for ViewPager. Again, by default on the master branch, but we can change that. So this also works for any of the source code that is available in the support library, the AppCompat libraries, or any of the other compatibility packages that Google has produced to go along with Android. Next up is the Android Resource Navigator by Jeff Gilfeld. This extension provides slightly deeper searchable access into the Omnibar for styles, themes, and other resources used by the platform. Additionally, XML and image resource references in the GitHub AOSP mirror are linked so that you can click on them to jump directly to their implementation without the need for another search. And in this case, whether or not you started that search from the Omnibar. So let's take a look at how to get this installed here in the browser. So if we're here at the web store, we'll go ahead and run a search for the Android Resource Navigator. And we'll see that this guy here is the one we want. So we'll pull that up there. And again, from the screenshot, you can start to see what this is going to provide to us. So the abilities to do some more searches of themes and widgets from inside the Omnibar there. So we'll go ahead and add that extension. Say yes. And we're ready to go. Now, similar to before, we're going to run these searches using a prefix. But where we used AD before, this prefix is going to be ARN space. And you'll see that it shows up with Android Resource Navigator to let you know what we've got available here. So for instance, with this, I can do a search for, say, a specific system theme. So let's use one of the common themes, the hollow light with the dark action bar. So I can start typing theme, hollow light. And again, you can see that as I'm going through this, it's providing me the results there till I can pick the one that I need as soon as it shows up. And I'm interested in looking at the theme for the dark action bar. So I can go ahead and hit enter there. And you'll notice this time it takes me to GitHub rather than the official web mirror of the AOSP, but it's the same code. So, and jumps me straight inside of the platform's themes.xml file to that exact style that I requested. So now I can look exactly at how this hollow light dark action bar theme is implemented in the platform. I can see all of the resources they use, all of the different style values. And I think the most important thing to look at is that all of these values are actually linked. Whereas if you were to look at this page without having this extension installed, these values would be here, but you wouldn't be able to click on them. So straight from here, I can say I want to look at this background image and see what they put, and it will jump me straight into that resource so that I can take a look. That I think over the searching of this is probably the most important piece of that this extension adds to the platform for you. So in addition to themes, I can search for really just about anything. I can search for widget styles. So if I want to look at how the text view or the edit text are defined in different themes, I can go ahead and pull those up. Anything that's defined in a resource file, you can search for using the Resource Navigator. So for instance, I could pull up the theme for alert dialog, and we could see how an alert dialog is styled inside of the Holo system theme. So again, once this comes up, we'll see it pull up. And you'll notice that again, we have all of the attributes here linked to their implementation so that we can kind of dive through this theme and see how did they implement something, do I want to do it the same way, what were those dimensions, all of those pieces. So last time I showed you a drawable, but for instance here, there's a number of different core layouts that are used in alert dialog. So I can, again, click on those layouts, and it'll jump me to another XML file. So I can just quickly look at that layout file from looking at the theme or style, and it's very fast, very seamless, a very efficient way of getting your way around the platform resources inside of the Android framework. When you get to the point where you want to dive a little bit deeper into the framework and system services, the browser environment can be a bit constraining. So let's move beyond this and see what we can accomplish with the command line tools that are bundled into the Android open source project. For this, we're going to first need to obtain a local copy of the source tree. So the best way to do that is if we go back here to the Chrome browser and we take a look at source.android.com. This is going to provide us all of the instructions that we need to obtain a copy of the Android source and basically get the specific version that we're interested in. So from source.android.com, if we click on the source link, there's a section over here for downloading and building. And underneath that section, there is an aptly named location for downloading the source. So these instructions are what we're going to just sort of simply walk through to get you a copy of the Android sources onto your machine. So the first tool that you're going to need to work with is a tool called repo. Now repo is essentially just a giant Python script that Google uses to allow them to more easily work with a large number of Git repositories that make up the individual projects of the AOSP and allow them to work with all of those projects and bring it into one single concise format that they can build together as the single Android open source project. So it doesn't have much specific use for us other than it's the tool that we're going to use to synchronize the source from the remote down to our machine. So if we walk through the steps, we can see here basically the steps you need to go through to obtain the repo command into your command line environment so that you can execute it. Once you have that on your machine, we need to initialize a repository where we're going to put the Android source. Okay? So the command that we're going to use for that is repo init. Now what you provide to repo init is a URL that represents a manifest of all the different Android versions that you may or may not want to check out. So in this case, for the Android open source project, we're going to use this URL that's here in the instructions for android.googlesource.com. Now, if you were to run this command just as it's shown here on the first line, what you would end up with is you would initialize a repository that would essentially check out the master branch of AOSP. But we talked before about the fact that individual releases of Android actually are branched or tagged by those specific names inside of the source tree. So if as part of checking out the sources you actually want to check out a specific version, then you're going to want to use this version of the command that's down here underneath that has the -b flag attached to it. So if you then instead run repo init with that same manifest URL and then the name of the branch you want to check out. Now this could be any of those tag references that we saw or any of those branch names like Gingerbread Froyo or KitKat. Then you just place that here and run repo init. Now what this command does is it sets up your environment to check out the version you're interested in, but it doesn't actually pull down any files. So running this command takes a little while, but it really does nothing more than initialize the tool. In order to actually get access to the source files, the next step and the final step is to run a repo sync. Repo sync is the process that will go through all of the individual projects that make up AOSP and download the appropriate version of the source code to attach to the branch or tag that you initialized with. So once we've gone through this whole process, and this sync will take a while, so you may want to do this and then go to lunch or go take a nap, because it's probably going to take a couple hours to get all of the sources down to your machine. But at this point, once we have a sync completed on our machine, then we can go through and actually investigate the files and sort of get a feel for how the structure is put together. So once we've downloaded the source, you should have a directory somewhere on your machine that looks like this. Now, this directory, in our environment, we just call it the AOSP directory, but you'll know you're in the right place when you see things like the device directory, frameworks directory, or the hardware directory, or the packages directory. So when you see a list that looks very similar to this one, then we're in the root of our source tree. Now, the very first step that we have to go through is we're going to set up the build environment using a shell script that comes along with AOSP called env setup. So the first thing that I'm going to run from the command line here is a source build env setup. The env setup script is in the build directory. That's all that means. And I'm going to execute that shell script. Now, the primary purpose of running this script is to prepare the build environment to compile an Android system image. It's setting up environment variables, paths, as well as some command line utilities. But it loads a good number of very helpful utility tools that actually are good for doing some of the source diving and investigation that we're interested in, even if we're not actually going to build the Android source. So for instance, there's one utility that gives you basically a list of all the other commands called HMM. So if I run the HMM command, I'll get a printout that looks just like this of some of the more common or more popular commands, as well as a complete list of everything that has actually been loaded into my shell for one reason or another as a part of running this script. Now, I'm just going to walk you through what I think are the most interesting commands for doing source diving, but if you're curious, you can look through all these commands here and see what they do. So the commands that I'm going to walk you through are the go-dir command, these grep utilities, and the croot command. So let's take a look at an example of this. The first utility that I want to show you is the go-dir command. Now, go-dir has a very specific purpose in that it allows you to provide a search string to jump anywhere in the Android source to any specific file that may match the search that you've provided. So let me give you an example. Let's say I want to look up intent service like we had before. From the command line here, I can type go-dir intent service and hit enter. And what I'm provided with is a list of possible options of all the different places inside the Android source where a file that matches intent service lives. So one of the nice things about this is I can provide partials, and I can then use, by picking a specific number, I can jump to a specific directory that has the file that I'm interested in without having to figure out what that directory is and then change my way all the way down there from the command line. So for instance, in this case, the one I'm interested in is the one in the frameworks directory, so I can just hit number 3, and immediately my path jumps to that directory there. I didn't have to do anything, it jumped me right into that location. So now I can just actually go and look at that file. And in this case, now I can see that exact same source code that we saw earlier in the browser, but now I'm looking at it locally on my machine using the command line tools that are available to us. So go-dir is extremely helpful because I can jump to any file pretty much from anywhere. So I don't have to go back to the root directory or anything like that. If I want to run another search from here, let's say I want to look for the notification manager system service, then I can just do another go-dir for notification manager, and again be provided with a list so that I can jump to that location from there. So I can just continually move my way around the Android source without too much trouble and not having to continually change directories up or down the tree. So as I'm tracing source code from one class to another, it's very easy to follow that path by just jumping from one file, even though those files may or may not be co-located in common places inside the Android source. Now that's helpful, but we don't always know exactly what file we want to look in next. So the next set of utilities that I want to show you are these grep utilities. So most developers are familiar with grep as it is inside of the system, but these wrappers such as jgrep, cgrep, mgrep, and resgrep are just wrappers around that core system utility that allow you to search through specific portions of the Android source for whatever it is you may be looking for. So for instance, as an example, let's say that I know there is such a thing called the receive boot completed intent. Most developers are aware of this or have used it before. But I want to look more about how that's actually implemented in the Android source. So let's start off by saying, well, let's look for a jgrep for receive boot completed, which is going to run a search for all of the Java source files inside of the Android source that match that particular string. Now you notice it didn't do anything, and I did that on purpose, because grep utilities, unlike GoDir, have to be run from higher up in the hierarchy, or at the very least from the root of the source tree. Otherwise it's only going to search from the current directory downwards. So what I really need to do is jump back up to the top of the source tree before I run this. Now I'm kind of deep in the source, so I don't want to necessarily have to type something like this, because that's just plain annoying. We've all had to do that before. There is another utility that is part of the build environment script that allows me to not have to do that, called croot. If I type croot from anywhere inside of the Android source, it will jump me back to the top of the source tree. So now that I'm at the top of the source, let's run that command again. And what we'll see is the result of where receive boot completed shows up in all of the Java source files inside of AOSP. So now I can go look at these results and say, all right, well, I'm interested in intent.java because that has some implementations in it. So I'll use my GoDir command to open that file up. So we figure out which one it is based on the path, and it's number 2. So then I can open that file. And then let's say I'm also interested in the Activity Manager service underneath. So right from where I am, I can go dir for the Activity Manager service. And in this case, notice it jumped there without any options. So one of the features of GoDir is that if your search string only matches one result, it will automatically change the directory for you. It will only give you the list of numbers if there's more than one option to select from. So from here, I can edit or open my next file. And I can open as many of these files as I'd like as I'm tracing through the execution or the implementation of how receive boot completed looks inside of the Android source. But that's not the only place where receive boot completed exists. Let's say that I know for a fact that because it's an intent, it's defined inside of an XML file somewhere. So I can use another one of these utilities called resgrep with my same search string. And if you're smart, you'll remember from the previous example that we have to jump up first. And this time, the results that I get back will be for all of the XML or resource files that are inside of the platform. So in this case, you'll notice that the one result that I receive is for the platform's Android manifest.xml file. So again, I can use my GoDir utility to find that. Now, I know for a fact that because there's a lot of applications in the Android source, if I just do a search for Android manifest, I'm going to get a long list. So for my GoDir, I'm actually going to provide part of the path inside of this search string so that it takes me to the right place. So I can open that file. And then I can actually look at the implementation of the receive boot completed string. Okay, and then when I'm all done, jump my way back up to the root. Now, there are again two more utilities that are based off of grep. In addition to jgrep and resgrep, there is also cgrep, which will allow you to run this exact same search through all of the C or C++ files that are in the Android source, and mgrep, which will allow you to run your search through all of the make files that are in the Android source. So if you're interested in looking at a specific module name or package information that is specific to one of the module builds when you build the system image, mgrep will look through all the android.mk files that make up the Android source tree. Lastly, I'd like to share with you some guidance to keep you on the right track. The Android source is a big place, but hopefully with these thoughts, we can help you find the signal among the noise. Most of the core system applications will be found in Packages apps. Source code for applications like Browser, Launcher, and Settings can all be found here. Additionally, a handful of applications also live in framework-based packages, most notably System UI, which is the application that is in control of all the System Chrome for the status bar, window shade, and soft nav buttons. Much of the framework is contained in framework-based core, with a few individual packages like telephony and location living in their own directories under framework-based. It is important to realize that the Android APIs are not entirely written in Java. Many of the framework classes have a native C or C++ component to them. AOSP typically segments these files into a separate Java and JNI directory, the latter standing for Java Native Interface and including those native components. The XML and drawable resources in the framework are located in the res directory of framework-based core. You will find this file hierarchy structured similar to what you would find in an application project, with XML resources in the drawable, layout, values, and XML directories, and image resources in the qualified directories, such as drawable HDPI. The platform also has its own Android manifest file, which contains the definition of published system elements like permissions. Many of the system-level activities and receivers are also published here. This is where we saw the implementation of receive boot completed in our deep dive example previously. Most of the system services available to applications follow a common implementation pattern as well. The classes that are accessible to the application, such as Package Manager or Notification Manager, are typically found somewhere in frameworks-based core and are very thin wrappers around method calls to a single service object that's running in a remote process. These service definitions, where most of the implementation code exists, are usually found in frameworks-based services with names similar to their corresponding manager, such as Package Manager Service or Notification Manager Service. As we discussed earlier, these services are usually not entirely written in Java and may very well include a native C or C++ component of their own. Because of this, the implementation is typically split between the Java and JNI directories. If you'd like to dive into more detail about how Android works, then I would encourage you to sign up for one of the upcoming Android internals classes that I'll be teaching for NewCircle. If you'd like to learn more about our work at Double Encore, you can visit us at doubleencore.com. Thanks very much for your time today, and I hope you learned something new.